All right, this is part 2 of our notes. Sorry, my phone turned off. So here we are. We're going to continue right on with our second example. Oops, over here. Oh shoot, where did my pencil go? Oh, Bojangles, did you take it? No, it's over here. Okay, I found it. All right, so we've got our pencil. We are ready. Okay, so if we have our triangle, just like we did in our PowerPoint, we've got side X, and we have side 7, and we have side 15. All right, so what I need to do is I need to use the Pythagorean Theorem. So I've got that written over here. And when I don't have A, B, or C labeled, I know that if I can find my right triangle, which is right here, and if I use that as a way to like go across, this side is going to be the hypotenuse. The hypotenuse is always the biggest side of your triangle. As long as it's a right triangle, it's the longest side. And compared to this number, I'd say this one's pretty big. But this one over here, since it's not across from here, that's how I know that this one is my hypotenuse. It's across from the right triangle. See how the right triangle kind of makes a point? It's kind of like an arrow pointing in this direction. That's how I know that this is my hypotenuse, the longest side of the triangle. So, that being said, just like over here, when I knew that this side was the hypotenuse, I labeled my A, my B, and my C. So I'm going to do the same over here. This side is going to be A. Oh, this likes to go out of focus. This is side A, and I'm going to square it so I remember to square my X. And this is my side B. I'm going to square it. And this is my side C, squared. So my A is X squared plus my value of B, which is a 7. So I'm going to put 7 squared equals my side C. That's 15 squared. So I don't have a value or a number here. So I'm going to leave that X squared. But I do have 7 squared. And 7 times 7 is 49 equals 15 squared is 225. Just to double check, let's use our handy dandy calculator. Ooh, it's all bright. Let's clear that out. We've got 7 squared. Enter. I should probably turn it this way. And we've got our 49. So we know that 49 is correct. And then 15 to the second power. If I type in 15 squared, I've got that, and I'm going to hit enter. 225. Bingo! Here we go. All right. So this one's a little bit different, kind of like how I wrote the word different up here. This triangle is a little bit different than the one we did over here. Here we had our A and our B, and we were trying to find C. Over here, we don't have A, we have B, and we have C. So it's a little bit different. We don't have our X. We have this, and we have this over here. So what I'm going to do, remember what you do to one side, you do to the other. I don't know why I just drew a line. But we're going to subtract 49 from both sides. Oop, there's our line. I didn't mean to draw this one. 49 minus 49 cancels out, and I'm left with X squared. Equals, I have 225 minus 49. 225 minus 45 equals 180. Did I say 45? I lied. 225 minus 49. I said 45. I meant 49. Oops. Equals 176. That's why it's always good to double check your answers in your work. So the next thing I want to do is I need to square root both sides. The reason for that is when I have a letter or number squared, like I do here, and I square root it, when I square root it, that cancels out and that cancels out. Kind of like what I said earlier, where if you have a positive one and a negative one, They both cancel each other out, and they give you 0. Same thing here. The square root and the 2 cancel out because they're inverses. They're opposites of each other, so they cancel out. But what I do to one side, I have to do to the other. Thanks, Bojangles. So I'm going to square root my 176. And I'm left with x over here, because remember the square root and the 2 cancel each other out, equals the square root of 176. So remember, we always, always, always have to check to see if this divides by anything. So the first thing I'm going to try is to take the square root of 176. So let's turn back this way. I'm going to do second square root, 176, enter. Ooh, I got a decimal. Now that doesn't always mean that we're going to get a square root, kind of like how we did on example 1. But we can at least try and divide it by 2, because it does end in an even number. We can try and divide it by 2, we can try and divide it by 3, sometimes 4, but sometimes the number is bigger. So let's go with 2. 176 divided by 2. What do we get? Ooh, we get 88. Perfect. It's a nice whole number that I did not plan for, but that works out perfectly. So we're going to do 2 and 88. And 2 is prime, so it's all done. And 8 times 11 is 88. And 8 breaks up into 4 times 2. 2 is done. That's done. This is done. 4 breaks up into 2 and 2. All right, so now that's the same thing as if I had the square root. This is kind of like our warm-up stuff, breaking these square roots down. 2 times 2 times 2 times 2 times 11. So I have 4 2's. 1, 2, 3, 4. So I have 2 times 2 times 2 times 2 times 11. Thanks, Bojangles. Perfect. All right, so he just wants to get in on this mathematical fun, don't you, buddy? What's he doing over there? Hi, Jangles. You're interested now? Are you up from your nap?
Yup.
Oh, okay. Well, we're going to go back to math. Enjoy your little nap watching the animals outside. Okay, so back to math. Sorry, guys. When we see two numbers that are the same under the square root, they cancel out and they hop outside. And we've got another pair, so that's going to cancel out and hop outside. Now remember, when we have two numbers outside of the square root, we have to multiply them. So don't forget that 11 is also left under here. 2 times 2, 4. Thanks, Bojangles. Root 11, because there was the 11 left under the square root, and 2 times 2 is 4. All right, so now to answer our question, what letter were we solving for? Goodness. Well, if we go back to here, it was x. We were trying to figure out what x equaled. So I can write x equals 4 root 11. So looking up at our triangle, that side of the triangle from here to here equals root 4, 11. Or 4 square root 11. Okay, so I can draw a little arrow up there. Perfect. All right. I guess I could put also here x equals 4 square root 11. Yay, perfect. Okay, so example 2 is done. So earlier I said, okay, this is the last problem. Yeah, well, we actually have one more. Definitely one more. Let me look here. Yep, definitely one more. Okay, so back to our computer. Come on. Oh, there we go. Example 3. Example 3. So we have to solve for x here. So this is just like the other example that we just did, just like example 2, where we have one side, which we can call A, and the other side is B, but here we don't have a value. This is our A. Remember, when it doesn't say A, B, or C, we can say this is our A, this is our B, and this is our value of C. But if I don't have a number here, That's okay. What am I trying to say? Let's set up our Pythagorean theorem. Okay? So, if we've got our triangle, the right side, yep, was right in that corner there.
I could have told you that.
Jangles, I don't need input from the peanut gallery.
Did you say peanuts? I like peanuts.
No, you're not getting a treat. Nice try. Okay, back to math. Here's 13. This side from here to here is 13. This side from here to here is x. And this side from here to here is 17. All right. Now, what we have to do is figure out which is A, B, and C. So I kind of already said it, but let's see if you guys remember. When it doesn't say which side is which, I know that this side across from here is what? Yep, the hypotenuse. Good. So if this is the hypotenuse, that means that's going to be my c squared. And does it matter which one is A or B? No. Typically, I'll always put whichever is on this side first. That'll be my A squared. Here's my B squared. And there's my C squared. Perfect. Pythagorean theorem. We should make Pythagorean theorem songs. I can also imagine some of you guys shaking your head saying, no Pythagorean theorem song. I wonder if we could find some Pythagorean theorem songs. That'd be great. All right, maybe I will. Maybe I will at the end of this. Okay, anyways, a squared plus b squared equals c squared. All right, so our value of a is 13 because we called this side a squared. So we're going to write 13 squared plus the value of b, which is x. I mean, technically, if this was a number, since I'm going by my numbers, x would be that. So I'm going to put my x squared. That's what I'm going to be solving for. Equals c squared. That's always going to be my hypotenuse. And we said the hypotenuse is 17. Oh my goodness. Jangles is hilarious. You have to see this. So he taps his little bag of food with his nose. Oh yeah, look at that. He was licking his lips. He taps that bag of food when he wants to eat. It's not dinner time yet, buddy. Okay, back to math. I'm so bad at this. Got to make YouTube videos fun somehow, right? Okay, back to this example. As soon as we're done with this one, wait, we're over here. As soon as we're done with this one, I promise, last one for the day, except a few extra practice homework problems. Okay, this is the lesson. Sorry, Jangles is so interrupting me. He's still licking his lips. It must be dinner time. What time is it? Battery's 5%. All right, that means I got to get going. Okay, time to charge my phone again. Back to this. So we have our a squared plus b squared equals c squared. Okay, so what I need to do, 13 squared, let's go to our calculator. 13 to the second power equals 169. Perfect. Plus my x squared equals, ooh, I don't have this one memorized, 17 to the second power equals 289. 289. 8675309. All right, so when I have a number plus x squared equals another number, I need to get this value of x by itself. So I'm going to draw a line to separate the two sides. And since I have a positive 169, I'm going to subtract 169 on both sides. Boop, forgot the 1. So I've got 289 minus 169 equals 120. I'm going to draw my line here. That cancels out. X squared equals 120. So remember, we have to square root both sides. Why? Because we're trying to get x by itself, right? And right now it has x. Ooh, can't even see. We're trying to get x by itself, and right now there's a 2 attached to it. So if I do the square root of x squared, the square root and the 2 cancel each other out. So I'm left with x equals the square root of 120. But now remember, always, always, always simplify. We love to simplify in class, don't we?
No.
Jangles, yes we do. You don't know this, you're not there. All right, gosh, she's so nosy. If I have x equals the square root of 120, I have to see what I can break that up into. I can break 120 up into 2 times 60. And I know that because if I have 120, remember, always try and take the number, and since it ends in an even number, it ends in a 0. I can take 120, and I'm going to divide it by 2. Always try and divide numbers by 2 if you can. See? 60. Perfect. So I have 2, which is prime. It doesn't break down any further other than 1 times 2. And 60, I'm going to go with 6 times 10. You might have chosen a different number. That's okay too. 10 breaks up into 2 and 5. 2 and 5 are both prime, so that's done. And 6 breaks up into 2 times 3. 2 and 3 are both prime. So now we can draw our square root. Okay, so we've got 2 times 2 times 3 times 2 times 5. How many 2's do I have? 1, 2, 3. 2 times 2 times 2 times 3 times 5. Do I have everything? 2, 2, 2, 3, 5. Perfect. Okie doke. So now we got to look for pairs. When I find two things that are the same, they cancel out and hop outside the square root. So that's done. But now I have a 2, a 3, and a 5. There's no more pairs. 2 is going to stay the same. And 2 times 3 is 6. And 6 times 5 equals 30. So there, my friends, is my final answer. We were solving for the letter x, so I can put x equals 2 root 30. So up here for my value of x, I can say x equals 2 square root 30. There's my final answer. So whenever you have a number with a square root like this, you can just leave it like this as long as it doesn't break down any further, kind of like how we did right here. Typically, you'll always see answers like that on a test or a quiz. You'll never really see them as a decimal, and that's okay. If you were to somehow make it a decimal, I'd probably accept it as an answer, but typically you're always going to see them as square roots unless they work out perfectly, which these ones did not, and that's okay. All right, so that's all I got for you today. Again, sorry about Jangles. He's a little nosy, tries to pretend like he knows math and he doesn't. So yeah, grab your calculators and we are going to try and do some practice problems for extra homework practice. All right, see you guys soon. Bye.